Hello, everyone. Welcome to the class. Today, let's look at the details of how your machines execute your instructions, the program instructions. Okay, so if you remember, this is what we talk in other videos. We have this control unit. This control unit have a whole bunch of details. And actually, there's a specific small details. It's a instruction counter, and we can also say it's a program counter. So this instruction counter, program counter, what's it actually do? You try to store the address of instructions. So if you have address of instructions, you can easily find what's the instruction look like. Is the instructions a move, or is this instruction a comparison? Is this instruction a arithmetic operations? So in this case, if you have a memory, we have a whole bunch of instructions here. We just remember the address of each instructions. And every time when we execute one, we will get the another one. So we run the execute instruction one, then we will update to instruction two, and so on. So this is how your machine actually got the instruction, the code you wrote to execute. Okay. So what it actually do? Actually, if you think about this instruction loading and try to do something and try to execute it, you can imagine that this is kind of a process. So what's the process detail look like? Let's see this picture. Actually, this picture give you a very good sense of what's the what's the execution look like. First of all, you have a programming counter. These programming counters here, it has some address stuff here, right? So these programming counters go to instruction registers here. These instructions will be fetch and decode. So you got the data, you got the code, the instructions, go to the fetch process. So where's the memory part? Because this is the address of instructions. Address instructions will access the data from your memory and try to do the fetch. So this is fetch. We got the instruction from memory to our machine, to our chip. And this chip will do a decode stuff. So if you see here's the decoder, the decoder will got the decode that got the instruction and decode it. Try to see what's the move, what's the action you want it to do. What's the instruction look like? So after the decode, the data will be passed to the execution cycle. Where's the execution cycle? Here. So this execution cycle, after you decode, you you got this execution cycle to run to do execute. Of course, if you want to do the move, you need to copy the data. If you want to do the arithmetic operations, for example, you want to do the sum of two variable to data, you also need to get data. So the after decode, after fetch is the first step. Decode is second one. Then the third one is get data. Because for most of the operation, you need to get the data to do a comparison, to do arithmetic computation, to do the copy. So get data, then you run the executed. Executed part is your ALU part here. It will execute the data and get the result. So the last step here is actually the execution. So execute the data and what's the result of the data? Back to memory. Okay, so this is the process of your instruction execution. For each instructions you have, you need one process, this one cycle. So we call this process a cycle. What the cycle means? Step one, two, three, four. After each step finish, we call it one cycle. For each instructions, if you want to execute it, you need one cycle to execute these instructions. Okay, and that's something I didn't talk about is here. There's something called register. What's a register? Why we get data from register, not the memory? Because memory is really far from your chip. It's really far. So actually, we provide another details. It's called registers here. The register is also memory. Is part of memory. It's the fastest, smallest memory in your computer. It's just behind, like sit behind the chip. You can see it's actually inside the chip. So we use this special memory to restore, like to remember the data we want to execute. This is kind of the part of the register. Why we need register? Because the memory is far away. So we use a small, this but really fast memory to support this computation. Okay, so this is how we do a cycle, how we do a execution of your instructions. Hope you got this idea. So today is a short videos. We just want to show you how to do the executions of your instructions. We just step by step check it. Actually, we just have a very simple 4-step. We get the instruction, we get the code, we decode it, we try to understand it. Then we get the data to support the operation, the command, the order you want to do. Then we execute it. So for after this 4-step, you got a cycle, you got the execution of the instructions. Okay, so hope you got this idea and hope you enjoy it. See you next time. The cycles is interesting.